Okay, so first example is we have this again na if you have time, please read what is this driven damp harmonic oscillator, what is um, force harmonic motion, katong resonance, kani what do you mean by resonance, force harmonic oscillation and so on. So tama na ta actually sa diri alang tataman sa dari no, diri tataman page saan nga page 105. Okay? Tama na ito sa damp harmonic motion nga system. Okay? So, recall, take note that there is this so-called quality factor Q, which is just equal to the angular frequency with damping omega d over the 2 gamma. Okay? So, this is our topic last time, no? So, we have this quality factor equal to omega d over 2 gamma. So, we derived this one last time, the quality factor Q. Okay, so let's have an example on damp harmonic oscillator. Take note ha, recall, oops, we have this in our last meeting, Q, the quality factor Q is just equal to uh, omega d over 2 gamma, where take note, omega d is equal to square root of so ito, omega square minus gamma square. Okay? Omega d is equal to omega square the angular frequency without damping minus the damping factor gamma. Okay, so let's have an example. Say example 2 point. What's an example? Example 3.4.1. Okay. Mhm. Example 3.4.1. Okay. So we have this. Dali lang nakalimutan. Okay. So we have an automobile suspension system is critically damped. Okay, take note. Ang yang condition is nasa damping but the damping is critically damped. Okay, so kining automobile suspension like kaning sa imong shock for example kaning nakay shock absorber for yeah shock absorber yeah. If nakay motor kinahanglan kag shock absorber para pag say for example na hump for example paglabay nimo sa hump, kung walay shock, kung walay ma-absorb nga shock, ang may tabo kay sige ra na siya kontrol-untol imong motor or imong sakyanan or unsa ba no. So kinahanglan kag damping nga factor para at least dili kay sa untol ang imong sakyanan or imong motor. Okay? So we have this one good application for damping is we have this kaning imong mga shock or automobile suspension system sa imong sakyanan. Okay? So, it is critically damped. So, what do you mean by critically damped? It means that your Q, katong gamay nga Q, no? Take note, when I say critically damped, kani, kung may ko critically damped, the Q, katong kani bitaw, no? Q, which is equal to omega, no? Omega, ano to? No, not omega, but gamma, sorry. It's gamma square minus omega square. Take note, ang Q is, take note ha, lay ang Q sa omega D, no? Omega D is just equal, this is for underdamped, no? Underdamped nga oscillator. Omega D is omega square minus gamma square. Take note of that, no? While your Q is gamma square minus omega square, okay? When it is critically damped, then kaning Q nga gamay, which is equal to square root of that, is equal to 0. It means that the damping factor is equal to the angular frequency. Okay, so muna ang meaning sa critically damped. And we have equation for that, right? We have the solution. We have the solution for critically damped. We know the solution for critically damped. Unsa kay ito? Na ako'y A, tama? Na ako'y uh, T exponential of gamma T minus gamma T plus B e to the minus gamma t. Sakto? So, this is for critically damped. Na kay linear linear nga term, and then naka-exponentially decreasing nga term for critically damped. Okay? So again, the automobile suspension system is critically damped and its period of free oscillation with no damping. What do you mean by this? Period of free oscillation with no damping, muni ang imuhang period nga T. Not the TD. Take note, lahi ang TD sa T lang, no? Ang TD is katong period with damping. Okay? Katong with damping na, mulahi man ang period niya, no? Tama ba? Kumutan mo damping factor, ang period kay I think mo less than sa period without damping. Okay? So given is that the period with no damping is equal to 1 second. Okay? Again, there's a difference between the T and the TD. TD means period with damping, while T is just period without damping. Okay? So given is that the T is equal to 1 second, and if the system is initially displaced by an amount of x naught. So your initial position is x naught, and it is released with initial velocity equal to 0. Okay? So given, so na given, no? Given is that your period is equal to 1 second, your x naught is your initial position. Okay? Initial position. While your v naught is equal to 0. Your initial velocity is given also, which is equal to 0. Okay? Notice, take note, v naught is just equal to x dot naught. Okay? X. Initial position x. Initial velocity. Initial velocity x dot. Okay? So the mo ang given, no? Question is, what is the displacement? Meaning sa displacement is what is x at time equals 1 second. Okay, so muna ang pangutana, no? What is x? What is the displacement at time equals 1 second? Okay, this is very simple. You have to take note that the system is critically damped. So it means that, so solution to solve for x, q is equal to 0. Okay, it means that your gamma is equal to omega. Okay, your damping factor is just equal to your angular frequency. And we know that omega, since omega, in terms of period, is just equal to 2 pi over t. Sakto ba? Tama? Omega is just equal to 2 pi over the period. So therefore, masolve na ko si omega. We have 2 pi over the period which is equal to 1 second. So therefore, the omega is equal to 2 pi. 2 pi lang, no? So if omega is 2 pi, then gamma is also omega, which is equal to 2 pi. So kabalo na ko sa gamma. Okay? So first na ko masolve based from the condition na your system is critically damped. I already solved the gamma or the damping factor gamma, which is just equal to omega, and omega can be solved using period because period is given without damping. Okay? Period is given without damping, and it is equal to 1 second. So therefore, omega is 2 pi. So therefore, gamma is also 2 pi. Okay? Gamma is also equal to 2 pi. The unit is per second. Take note, same ang unit ni gamma o ni omega. Okay? So that's my gamma. So nakuha na ko si gamma. Also, take note that for critically damped, take note for critically damped or critical damping, I know the equation for the solution, no? Na ko xt katong isulat, no? Uh, at exponent of gamma t plus b e to the minus gamma t. If I factor out the exponential function, na ko at plus some constant b. Okay, so this is the general solution of of the system if the system is in critically damping na if you put critical damping factor in your system. Okay? Okay, so ang ipangita, take note, is ang displacement at t equals 1 second. So ang problema ni is that we know gamma, tama? We know gamma, so check na ni siya, no? But we don't know A, we don't know B. Sakto ba? So we need the specific solution for the system sa kaning problem. So what we need is we don't know this, we don't know A, we don't know B. But we know gamma, take note is equal to 2 pi. Sakto? So, kabalo na ko ni gamma. So, may problema ni gamma. So, how are we going to solve for A and for B? Unsa kay ito? Always na to dumduman nga basta constant gali ang kuhaon. Same kung moadto ka sa electromag, moadto ka sa quantum mechanics. Same ra ni sila og setup gid always. If ang imong kuhaon is ang mga constants A and B, always dumduman ninyo ma-solve nimo ning mga constants using initial conditions. Okay? Take note of that. Bisag moadto ka sa quantum, bisag moadto ka sa electromag, always basta constant imong solvon, you need to you can solve this one if you have initial conditions. Sa electromag gitawag siya sa electromag sa quantum mechanics gitawag siya nga boundary conditions. Okay? Boundary conditions are like initial condition nga naa sa imong system. Okay? So once na ako'y conditions, boundary conditions, then masolve na ko ning mga constants A and B. So unsa ang mga conditions, unsa ang mga initial condition niya sa problem? Nakoy duha ka initial condition, no? Akong mga initial conditions are the x naught. So ingani pag-solve sa mga constant, no? Initial conditions are the x naught, the initial position, and the VO which is equal to 0. Okay? Solve mo na to first. When you're at time equals 0, your x naught is equal to x naught lang. Okay? Again ha, if mo solve kag mga constants, always automatic mo tatak sa diretso unsa nga mga initial conditions, unsa nga mga boundary conditions ang nasa imong system in order to solve for the constant. Okay? In order to solve for the constant. So there's no problem with gamma because we can solve gamma using the concept of kaning q ni mga gamay which is equal to 0 for critically damped. Okay? So I can solve for gamma. I only need two equations because I have two unknowns, right? Nakoy duha ka unknown lang, the constant A and the constant B. So what I need is at least two equations to solve this A and B. Okay? So nakoy duha nga makuha actually, no? At time equals 0, your x is equal to x naught and your v is equal to v naught which is equal to 0. Okay. So first, at time equals 0, kung taon mo, no? Sa kaning equation, at time equals 0, what will happen to your solution? Nakoy x at time equals 0, substitute the 0, no? Nakoy a times 0 e to the minus gamma times 0 plus b e to the minus gamma times 0. And what is x at time equals 0? Kung sa itong initial condition sa x gani at time equals 0, this is equal to x naught. Sakto ba? At time equals 0, your x is equal to x naught. Okay. So we have x naught equal to, this one is 0, right? A times 0 is just 0. So, kanin sa kama 0. So, nakoy 0. Oops. Nakoy 0 plus b, e to the 0 is 1. Sakto ba? E to the negative 0 is 1. So, nakoy b, e to the 0, which is just equal to 1. So, as you can see here, nasolve na ako si b. B is just equal to x naught. Okay? So, sayon ra, no? Nakuha na ako si x naught. Tama ba? Nakuha na ako si b nga constant, which is equal to x naught. Now, saan ako pag-solve ni a? I cannot solve for a if I use this condition x equals x naught at time equals 0. So, dito ka sa ihang velocity. Okay? At time equals 0, your initial velocity is equal to 0. What do you mean by initial velocity? If you derive the x, okay? Muna akong x, no? Muna akong x, no? If I derive that one, what I will get na ko x dot as a function of time, i-derive lang na ko ning x dot na ko. Saan gani pag-derive gani? I use product rule, no? If I use product rule, na ko e to the minus gamma t, na ko at plus b, I will derive this one, no? I will derive this. I call this one as prime. Okay? Prime means, dili prime ang gamit. Dapat na, dot dapat, no? Pwede ra dot. Dot ba? Yes. Dot. Pangit man lang taon. Ano na lang? Ano na lang akong gamiton? DDT na lang akong gamiton, no? DDT. Okay? So, this is my velocity, right? If we derive the x with respect to time, that's, makuha na ko ang velocity as a function of time. So, saan ako ni pag-solve? Dali lang, no? Nakoy x dot equal to, using product rule, this is equal to e to the minus gamma t times derivative of at plus b, that is equal to a lang, sakto? Plus at plus b derivative of e to the minus gamma t is e to the minus gamma t times minus gamma. Sakto ba? Tama ba ni? Sakto no? So I have x dot equal to a e to the minus gamma t plus minus minus gamma at plus b. Sakto? E to the minus gamma t. Tama ba? If I factor out the e to the minus gamma t, na ako'y makuha nga no? If I factor out the e to the minus gamma t, na ako'y mabilin nga a minus gamma at minus gamma b. Okay? This is my velocity as a function of time. Okay? This is my velocity as a function of time. Napakoy a minus gamma t minus gamma t. Okay. And take note, sa ito, at time equals 0, so nakoy x dot at time equals 0 is just equal to 0 because your initial velocity is equal to 0. So if i-substitute na ko ang time equal to 0, so what will happen to this equation? This is e to the minus gamma times 0 times nakoy a, tama? Minus gamma 80, sakto? Minus gamma a times 0 minus gamma times b. Okay, so this is 0. This is e to the 0 is 1. Nakoy a. Kani kay ma-0 na siya, no? Ma-0 na siya. Nakoy a minus gamma b. So therefore, as you can see here, a is just equal to minus gamma b. Dili. Plus gamma b, no? Our a is equal to plus gamma b. And we know b, right? B is equal to x naught. Since b is equal to x naught, so therefore a is equal to gamma times the x naught. Again ha, muna yung nakalinot no? Kung magkuha, same sa differential equation ninyo, kung kadamdam mo sa differential equation, if I want to solve for the constants, then I have to, I need the initial condition sa imong system. Okay? Sa electromag, we call that one as boundary condition. Sa quantum mechanics, we also call that one as boundary condition. So same lang sila, initial conditions or boundary conditions. Okay, so I know now A equal to gamma x naught and B is equal to x naught. So therefore, thus, the solution, meaning kung may solution, akong giko ay isang x of t. X of t now is equal to, so ito, e to the minus gamma t, at plus b, sakto ba? This is equal to x to the t, e to the minus, take note, gamma is what? A is kana, b is equal to x naught, okay? And then gamma is equal to, sa itong gamma gani, 2 pi. Okay. Gamma is equal to 2 pi. So therefore, na ako'y 2 pi t, tapos a is equal to gamma x naught t plus x naught. Okay? So, if I factor out the x naught, x as a function of time, equal to x naught e to the minus 2 pi t times gamma t plus 1. Okay? So, this is now your final solution or your x as a function of time t. And, kung sa ipangita gaya nato gani, ang ipangita is what is the displacement at time equals 1 second. So, dali lang, no? Igora nimo i-substitute ang time equals 1 second. So, therefore, at time equals 1 second, we have x which is equal to 1 second. So, substitute lang nimo, no? Na ko'y x naught. So, asa nakaroon ng particle at time is equals 1 second. So, na ko'y e to the minus 2 pi times 1. And then, na ko'y ay gamma, no? Gamma is 2 pi. Take note. This one is 2 pi. Illusion lang ako, no? This one is 2 pi. Because gamma is equal to 2 pi, no? Nakoy 2 pi. Okay? So, therefore, this is 2 pi times 1 plus 1. So, if you solve this one, this is equal to x naught e to the minus 2 pi 2 pi plus 1. And using your calculator, kani siya, kaning term is just equal to 0.0136. 0.0136. Make sure that your calculator is on radian mode. Okay? Take note, ang imong calculator kay dapat naka-radian mode. So therefore, at time equals 1 second, the position, the displacement is just equal to 0.0136 x naught. So somewhat nasa duol sa equilibrium niya nga position. Sakto? 0.0136 na nasa dapit sa 0 nga equilibrium position. So, kung may napugag at time equals 3 seconds, dali lang, no? Ikuha mo substitute ang time equals 3, then you will get your displacement. Okay? So, ingana lang siya pag-solve. Nakuha. Dali ra ba, no? Dali ra man siya, no? Because I have the solution. You will get constants using initial conditions. And then from that, masolve mo ang displacement at any given time t. Okay? So, that's 0.0136 x naught. Okay. Another example. Do you have any question? Okay ra, no? Haba may question?
Okay ra, sir.
Okay ra, no? Sige. Mayo. So, yeah. Next problem is we have problem 3.4.2. Okay, 3.4.2. Tawa na to no? For 3.4.2, I have the system is this. The frequency of, take note, a damped harmonic oscillator. Wala siya nag-specify unsa nga klase, no? Critically damped pa siya, underdamped pa siya, or overdamped siya. But ang ingon that ang frequency is ni gamma, no? The frequency of the damped harmonic oscillator is 1/2 the frequency of the same oscillator but with no damping. Question is, find the ratio of the maxima of successive oscillation. What do you mean maxima of successive oscillations? We call that one as amplitude. Okay? Ang pinakataas niya nga makuha sa imong oscillation at a given time t, that's your amplitude. Okay? As you can see, for harmonic oscillator, okay, solution. Take note, sa harmonic oscillator, this is for harmonic without damping, no? Without damping. So basically, harmonic oscillator lang siya, no? The x can be written as a cosine of omega t plus some phase angle phi. But with damping, I call this one as damped harmonic oscillator. Damped harmonic oscillator. Kung kabantay mo sa yung general lang equation for damped sa tawag damped harmonic oscillator, dili na A ang yang amplitude but nana siya some exponent e to the minus gamma t. Sakto ba? Nana siya some exponent e to the minus gamma t. So, somewhat ang iyahang ratio, nakoy ingani, no? Nakoy ingani, a e to the minus gamma t of some function there. Sakto? Critically damped, overdamped, o underdamped, nasa somewhat amplitude equal to this one. Okay? Mugamay man gid ang amplitude, sakto ba? Because of damping, mugamay ang yang ang yang amplitude. So if you take the ratio, as you can see, the ratio of its amplitude of this one, kaning without damping or with damping, if you take the ratio, what will you get is we have e to the minus gamma t over a, which is just equal to e to the minus gamma t. Sakto? This is now the ratio of its of the maxima of successive oscillations. Okay? Sakto ba? Yeah. The amplitude for harmonic is just A, while for the damped harmonic oscillator is na siya somewhat term for exponentially decreasing na function. Okay. Now, the given is that the frequency is 1/2 the frequency of damped harmonic oscillator is 1/2 the frequency of the same oscillator with no damping. So meaning 1/2 lang ang frequency ni damped harmonic oscillator sa frequency na harmonic oscillator, and that's the meaning of this sentence statement here. Okay, so it means that the frequency for damping is just equal to the frequency of the oscillator without damping. So muna yung meaning, no? This is angular frequency, but take note, angular frequency is just equal to 2 pi, no? 2 pi f. So, same ra sila. Mag-cancel out lang 2 pi there or what. Okay? So, we have this. And recall, take note. Recall, uh, yeah. Recall, take note that the omega d can be written as omega square minus gamma square. Sakto? The omega d, the angular frequency damping, can be written as square root of omega square minus minus gamma square d. Minus gamma square. So, if you equate these two, what will you get? Kung equate na ko ng duha, unsay makuha na ako? Na ako'y expression ni omega in terms of gamma. Sakto? So, if I equate that one, square both sides, you will get 1/4 omega square equal to omega square minus gamma square. Sakto? If you take square root both sides, if you take square roots both sides, you will get this. And from this one, you will get gamma square is equal to omega square minus 1/4 omega square. Sakto? So therefore, gamma is just square root of 1 minus 1/4, that is equal to 3/4 omega square. Or you can solve for gamma, which is equal to square root of 3/4 omega. Okay. So nakuha na ko si omega based from the expression, or based from the equation for our omega d with damping. Okay? With damping. So square root of 3/4 times the angular frequency without damping. Okay, so that's my gamma. Also, oh yeah, that's my gamma, no? Ang atong ipangita is the ratio. Take note, ang atong ipangita is the ratio, and we know that ratio is just equal to e to the minus gamma td. Td is the period with damping. Okay? Period with damping. We know gamma. Gamma is equal to square root of 3/4 omega. While td, we can solve for td from uh, kung saan ako pag-solve ni td karon. Yeah. How to solve for td? Yeah. Gamma td, I can solve for gamma td, which is just equal to 2 pi over omega d. Sakto ba? 2 pi over omega d ba ang sakto na ni? Nabanis na sa ato ang okay, nato na. Yeah. The period, take note, the period is equal to 2 pi over wala dapat ni gamma. The period is equal to 2 pi over gamma d. So period rin isa, no? Period, wala ni gamma. Period, take note, with damping is equal to 2 pi over gamma over omega d. Okay? So 2 pi over omega d, and pila ni siya? Omega d kay given man ang omega d, no? Ito ba? Given sa omega d. So we have this is equal to 2 pi over 1/2 of the omega. Sakto? So therefore, this is equal to 4 pi over omega. Okay? So this is your period with damping. Okay? Period with damping. If you put this one here, so the ratio becomes, yung ratio now is equal to e to the minus gamma td. And I know gamma, this is equal to minus gamma is equal to square root of 3/4 omega times td nga 4 pi over omega. You can cancel out the omega. I can cancel out the omega. So therefore, the ratio is equal to e to the minus pila ni 4 pi square root of 3/4. Sakto? And this is actually equal to e to the minus 10.88, or if you use your calculator, this is equal to 0.00002. Okay? 0.0002. Okay? So this will be your answer. This will be the ratio of its amplitude without damping and with damping. Okay? Without damping and with damping. Take note, ha? The period with damping is equal to 2 pi over gamma d over omega d, sorry. 2 pi over omega d. And since omega d is just half of the omega, angular frequency without damping, so you can have this period with damping 4 pi over omega, substitute that one to our ratio, and then gamma is equal to square root of 3/4 omega, then you will get the ratio of your um, successive of your amplitude, okay? Of your amplitude. It's 0.00, ay kulang isa. 0.002. Okay? That's your, that will be our answer. Sakto ba? Square root 4 pi, na 4, sakto na, no? 10.88. Okay? That's negative 10.88. Okay. Any questions? Okay na, no? Sa'yo na? Wala question? So that we can go to our last example. Okay? We can go to our last example. Okay na? Sige. Last example is this. Please read example 3.4.3. Basahan. Sana. Please again study example 3.4.3. Okay? Study example 3.4.3. So, skip lang ako na. Let's go to our last example. Calculating the quality factor Q of the oscillator. Okay? So, 3.4.2 is this. Suppose we have a spherical ball of radius 0.00265 meters and ang mass niya is given by this, which is attached to a spring of force constant gamay nga k equal to 0.05 para mo stretch sa gayo po, no? And then ang mass nimo is set to oscillate under the action of the spring. The coefficient of viscosity for water, okay, since ang imong bola para na dumping, ang dumping ani nga part is naa siya sa na kay mass spring system, you put it in the water and then you oscillate mo sa dito, what will happen is your system now is a damp harmonic oscillator. Kung nakita mo sa thesis proposal nilang Acebo, gitawag po siya nga Brownian harmonic oscillator. Okay? Brownian harmonic oscillator. But ang pinaka-common nga term is this damp harmonic. So nasa kalahian ang duha, no, take note, dili parehas actually ang Brownian harmonic oscillator o damp harmonic oscillator. Lahat na sila. Ang Brownian is nasa base, ang field niya is on statistical mechanics ng field, while the damp harmonic is nasa sa classical mechanics ng field. Pwede po ka mag-quantum mechanics ng field. Okay? So, nag-involve og water with viscosity equal to 10 to the minus 3. Question is, what is the number of oscillation that the ball will execute in the time it takes for the amplitude of the oscillation to drop by a factor of 2? So, may tabo man god, kung nakoy spring, no, ang may tabo niya is nga nakoy spring, tapos nakoy bola with radius r, which is given, and then you put it in a water, okay? And then, pag-release mo na, oscillate na siya, no? There will be an oscillation of your object. But without this water, ang mahitabo kay di na siya muhunong, right? Dili mo decrease yung amplitude. But since there is this water, ang mahitabo magkahinay o magagamay ang amplitude sa imong oscillation. Okay? So question is, kapila mo oscillate ang imong bola in such a way that the oscillation will drop, the amplitude of the oscillation will drop by a factor of 2 from its initial value. So meaning, kung amplitude nimo is 10 meters, then kanos pila ka oscillation ang naa angtod sa mo abot og 5 meters na lang iyang amplitude. So ingana ang pangutana, no? Find the number of oscillations that the ball will execute in the time it takes for the amplitude of the oscillation to drop by a factor of 2 from its initial value. So therefore your A is equal to 1/2 of the initial value A naught. Okay? And for the B question, calculate the quality factor of the oscillation. Okay. When you say viscosity eta, okay? There is this, take note, as you can see, the kadumdumatong E dot is equal to CX dot square. Sakto? For 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 this problem, the constant C is not an unknown number, not an unknown constant, but there is an equation for this sa fluid mechanics. Take note sa fluid mechanics, C here is equal to 6 pi eta times the radius of the spherical ball. Take note of this. In fluid mechanics, na ako'y formula for the constant, okay, with damping. Okay, kung na ako'y damping, say in terms of viscosity, the C or the constant C here is equal to 6 pi times eta times the radius of the ball. So meaning, makadako na yung spherical ball, makadako po na ning constant nga C. So makadako ang power nga mag-dissipate kung dako po ni mga bola. Sakto? So na ako 6 pi eta r. So don't worry about the formula. Given ni dapat ni siya, no? Given dapat ni siya. So no need to derive it. Kay the derivation of this is, nakalimut ko sa pag-derive niya. Or, higit sa pag-derive mo. Nga nung na 6, daghan pa na sa story, no? Na sa story. Anyways, so, see, the constant here, kaninga constant, when you put the object in the water, then there will be this specific constancy aning a system, which is equal to 6 pi and r. If you do this, if you solve this one, this is 6 pi times 8 nga 10 to the minus 3 times r nga 0.00265. What you will get is the constant is equal to this 5 times 10 to the minus 5. The unit is Newton second per meter. Okay? So, masolve na ako si C daan. Okay? Masolve na ako si C daan. Because take note, si gamma is related to C, right? Gamma is related to C. Tama ba? So, gamma is related to C. So, once masolve na ko si C, masolve na ko ang gamma. Okay? Masolve na ko ang gamma. And because your amplitude is also related to gamma po, no? So, kinahanglan ginato solve mo ng C. Okay? So, that's my C. Question is, for letter A, the amplitude dies away as this. A is equal to A naught e to the minus gamma t. Sakto? The amplitude, magkagamay ang imong amplitude as a function of time, which is just equal to this one. So that's why katong gingon kay na, no? If you take the ratio between the harmonic ug damped harmonic oscillator, ang makuha nimong ratio is just this, e to the minus gamma t. Okay? E to the minus gamma t. I know gamma. Gamma is equal to this. Since gamma is equal to 1 over 2 tau. Sakto? Tama ba? Nasa expression for gamma in terms of this characteristic time or some constant time, tau. So you can actually write A as A naught, where A naught is the initial amplitude, right? Take note, A naught is the initial amplitude, while your A is the amplitude as a function of time. So nakoy minus T over 2 tau. So pwede na ako masulat ang amplitude equal to this expression here, minus T over 2 tau. Okay. And take note, if you take the ratio, okay, if you take the ratio, A over A naught, what will you get is equal to 1/2. Sakto ba? Which is given. Yes? Nangutan na. Yes?
Sir,
Yes?
agi ka lang kwan sir, 1 over 2 tao nga kwan sir sa kaning gamma.
Kani, no? Kani siya. Naani siya last time sa katong pag-solve na to using, pag-solve na to on quality factor. Okay? Itong pag-derive na to sa quality factor, naani siya we let the gamma there as 1 over 2 tau, where 2 tau is somewhat, we call this one as time constant. Okay? So, it's just a change of variable. It's just a change of variable in terms of some characteristic time tau. Okay? Okay ra?
Okay na sir.
So,
Salamat.
okay, nana siya, no? So, nani siyang definition sa ako ang gamma. Okay? So, again, in the question, ang sa question is, kanus or pila ka buok oscillation ang naa if the amplitude becomes half. Okay? So, therefore, kung ano ang ratio, A naught equals 1/2, which is equal to e to the minus t over 2 tau. Okay? And then, from this, I can solve for time. Masolve na ko ang time dire, no? Solve for time t. Solve for time t using, saan ako ni pag-yung time t gani? na ako'y 0.5, no? 1/2 1/2 equal to e to the minus time over 2 tau. If I take ln both sides, if mag-ln ko both sides, what you will get is ln of 1/2 equal to minus t over 2 tau. Sakto? Tama? If I take ln both sides, you will get this. So therefore, time is equal to negative 2 tau of ln 1/2. Okay? And you can also have, using the definition of ln, minus 2 tau. If I take this, 1/2 take note can be written as 2 to the minus 1. Sakto? You can express 1/2 as 2 to the minus 1. They are equal, no? So therefore, na ako'y property sa ln nga, if I have an exponent, then you can bring down the exponent here. So therefore, the tau can be written as 2 tau of ln of 2. Okay, take note ha. See, time t, I can solve for time t, which is given only in terms of time constant tau, which is equal to 2 tau ln of 2. So nawala ang negative, no? Kaya tungod na negative 1 dari, no? Ako negative 1 times negative 2, that's positive. Okay, so na ako'y time t is equal to 2 tau ln of 2. Now, na-solve na ko si time t, I can solve now the oscillation, the number of oscillation. Thus, the number of oscillation is given by this. I let the number of oscillation as n, not eta, but n, during this time, which is equal to this. N is, not eta, n rin siya nga normal n. Omega dt over 2 times 2 pi. Anong omega dt over 2 times pi man isa, no? Omega dt is just katong distance. Ang distance nga ma-travel sa imong oscillation at sometime t over 2 pi because isa ka oscillation ang iyahang ma-cover nga distance is equal to 2 pi. So that's why nakoy omega dt over 2 pi. Okay? Take note, the number of oscillation can be written as this omega t over 2 pi. Okay? So therefore, ano ka rin eh? Number of oscillations is equal to over 2 pi. Take note, isa ka oscillation kay isa ka tuyukan, that is equal to 2 pi. Okay? So ihapon lang nimo pila ka 2 pi ang natuyok, no? So that's why we have omega dt over 2 pi. So we have
Formula na
yes.
Formula na siya sir kanang n.
Yes, that's correct. Sama. Okay. Yeah, that's correct. The number of oscillation is equal to omega dt over 2 pi. Yeah. And then we have omega d. Na-solve na ko ang time, no? Which is equal to 2 tau ln of 2 over 2 times pi. So I can cancel out the 2. Ma-cancel out na ko ang 2. So the number of oscillation now is equal to omega d time constant tau ln of 2 over pi. Okay. Aha. Unang tao na to, kaning omega dt is just equal to q. Sakto ba? Q ra ba ning omega dt over 2 pi? Take note. Katong isulat, pinakauna na akong isulat. Ito. Ganito. Tanda. Omega d over 2 gamma is your q. Okay? Omega d over 2 gamma is our q. Okay? Ano to? Okay. Aha. Take note. Note that quality factor q is equal to omega d over 2 times gamma. Sakto ba? 2 times gamma ba na? Yeah, sakto no? 2 times gamma. And I also know that 1 over 2 gamma is equal to tau. Sakto? Gamma is equal to 1 over 2 tau. So therefore, tau is equal to 1 over 2 gamma. So therefore, kaning Q is equal to omega D times tau. Sakto? Times tau. So therefore, as you can see, kaning omega dt is just equal to Q. Okay? So, kung lang tawag mo, the number of oscillation can be expressed in terms of quality factor 2. So your n, the number of oscillation n, can be written in terms of quality factor equal to Q ln of 2 over pi. Okay? Tama ba? So, take note, this one, omega d tau is just equal to the quality factor Q. So that's why you can express the number of oscillation n equal to Q ln of 2 over pi. Aha. So, masolve na nako si Q. Masolve na ako si Q. Masolve na ako si Q, no? Take note Q. Solving first the quality factor. Solving for Q, which is equal to omega d times tau. Okay? And this is equal to uh, tau can be solved using this 1 over 2 gamma, which is equal to 1 over 2 times c over 2m. Sakto? Because gamma can also be written as, take note, gamma can also be written as c over 2m. Okay? So, na relationship si constant c, nga ito na-solve last, formiro na ito nga calculation into gamma, which is equal to that. So, therefore, na ko 1 over c over m, which is just equal to m over c. Okay? M over c. And we know m, m is just given, m is given, m is equal to this, 5 times 10 to the minus 4. Okay? So, 5 times 10 to the minus 4 ang m, no? 5 times 10 to the minus 4 kilogram. While my c is given also, c nako kay, nakuha na itong c, no? 5 times 10 to the 5. 5 times 10 to the minus 5. So, therefore, my tau is equal to 10. The unit is seconds. Okay? This is my tau. The unit is 10 seconds. The unit is seconds. And the omega, omega d is just equal to square root of omega square minus gamma square. Okay? Minus gamma square, which is just equal to 100 minus 0.0025. So 100 minus 0.0025. Question is asa ni gikan? This is equal to yeah, this is equal to 100 minus 0.0025 square root, that is equal to 10, around somewhat approximately equal to 10. Sakto ba? Anong 100 man ang omega? Asa gikan ang omega? Take note, omega square is equal to k over m. Okay? K over m. So, k is given, it's 0.05. And then mass is 5 times 10 to the minus 4. This is actually equal to 100. Okay? This is equal to 100. Okay? Gamma is also given. Gamma, the omega square is 100. Gamma square is just equal to 1 over 2 tau square. Sakto? And we know tau, right? We know tau is just equal to nakuha itong tau, no? Tau is equal to 10 seconds. So, nakuha 1 over 2 times 10 quantity square. This is actually equal to 0.0025. Okay? So, the gamma square is 0.0025. 200. Yeah, 102. So, the omega d is just equal to 10. So, the quality factor Q is equal to omega dt tau. Sorry. This is 10 times the tau, which is also equal to 10. Okay. So, this is equal to 100. The quality factor is equal to 100. Okay. So, therefore, the number of oscillation is Q ln of 2 over pi. So, nakoy 100 ln of 2 over pi. So, this is basically around approximately equal to 22. Okay? So, the number of oscillation is equal to 22. So, ka-22 sa may isolate, adi sir ma-half ang yahang iyang amplitude. Okay? Mahap ang iyang amplitude. So that's the number of oscillation sa kaninga problem. Okay? Do you have any question? Yes?
None, sir.
Okay. Pili rin. Nakay question, pili rin.
Unsa ito kuan gani sir unit sa C?
C is NS over M. Newton seconds per meter. Yeah. Newton seconds per meter. Yeah. That's the unit of C. That's the unit of C. Ano to? Wala. Kana na. NS over C. Over M. S ni siya, no? S. Okay? Any more questions? Stop na ako ng recording.